Hello, so let us look at some practice questions for the upcoming exam. So first we have to construct a bisector of the angle. Now, that means we need to take out our compass and our ruler. There it goes. So, first take out your compass, put one leg of the compass at the vertex of the angle, and you can just open it up. Doesn't matter how much, but just open good amount of distance, and then you're gonna draw an arc. Now, bring the compass one more time to the intersection between the arc that you just have drawn to the one of the ray, and make sure that your compass is open more than halfway of the spread of the angle. So it seems like we have done it. Draw an arc. Now you're gonna do the same thing. Put one leg on the other intersection without changing the width, and draw the other arc. Now then what you have to do is simply connect the vertex and then intersection. So now you can see that green line is supposed to be the angle bisector of the given angle. So now this is a picture of that one example, just like how we have done it. This is a bisector of the angle ABC. Then which statement is not true? EBF. What is EBF? EBF. So this angle, is that the half of angle ABC? ABC of the entire thing? And that is true. This is only one half of the whole thing. How about the second one? DBF. DBF. We're looking at upper portion of the angle. That's half of the whole thing, isn't it? Same thing is written. How about number 3? EBF. EBF. We're looking at the bottom angle. Is that the same as angle ABC, which is the entire angle? No, that's not. So that's not true. Choice 3 would have been the answer. Now, let's try to look at number 3. Construct perpendicular bisector. How do you construct perpendicular bisector? Take out your compass and a ruler. First, bring the compass to the one end of the line segment, and make sure you open up more than halfway of the line segment and draw an arc. And without changing the width, you will do exactly the same thing on the other side. Now, then you will see that one top and one on the bottom, the intersection between those two. So now, you can bring your ruler, and I'm just going to use the blue. Right? So if you connect those two intersections, you will see that that would have been the perpendicular bisector of the line segment that's given. Alright, let's look at number 4. You can see that that's what's given. Then in other words, AC must be equal to CB. Now, which statement is not true? AC is equal to CB, that's correct. CB, which is one portion of the line segment, is that the whole thing of AB? Yes, that's true. It's AC 2 times of AB. No, that is not true, because AC is in fact half of AB, not 2 times of that. So that would have been our answer. Now, using a compass and a straight edge. Alright, so compass and a straight edge. First, what I need you to do is this. Bring your compass to the point. And you open up the compass a bit more than the given line. And draw an arc like this way. Then now this, you can consider these two as the endpoints of the line segment. just like earlier. And then you can make sure that you just go more than halfway and draw an arc. Or if you want, you can just draw an arc all the way through, it doesn't matter. And go to the intersection between the original the first arc and then the line segment. And you draw the other arc. Now, then what you can do is, you see these two intersections, but if you have to draw the line, you will see that it will pass through that point. Hence, it's going to be perpendicular passing through that particular point. Now, number 6. This is construction of the parallel lines. Notice that these are corresponding angles and they're equal to each other. So which statement justifies this construction? Yes, angle 1 and angle 2 has to be congruent to each other, which would be choice 1. Now, equilateral triangle with a edge ABC. That means first I need to open up a compass and a ruler just like earlier. Now, first what I need to do is put on one leg on the line segment and then open it up to measure the given line segment and then draw a little arc. Now that tells me that I just measured how long the given line segment is. And then I can bring it up and draw an arc over here because my vertex of the triangle would have been somewhere around here. Without changing the width, bring the compass to the other side and draw another arc. Then you will see that the point where they meet up, that is the one of the vertex of our triangle. So I'm going to go from here, A. Alright, and then second, connect it. So now that becomes our equilateral triangle. Alright, number 8. The angles of the triangle are in the ratio of 8, 3, and 4. That means we have 8x plus 3x plus 4x. They have to be equal to 180 because sum of the interior angles of a triangle is equal to 180. So when you combine them together, we get 15x is equal to 180. Now, if you divide by 15 from each side, then the value of x now it becomes 12. So now 12 is x, but it's not the measure of the angle. Our smallest angle would have been 3x. So therefore, 3 times 12, which is equal to 36, becomes our smallest angle, choice 3. Now, next, number 9. We have 3 angles given in this way. What is the value of x? So once again, since these 3 angles makes up a triangle, what we can do is when we add them up, it becomes 180. So x plus 2x plus 2 plus 3x plus 4 has to be equal to 180. Now when I add them up, I get 6x plus 6 is equal to 180. Now by subtracting 6, we get 6x must be equal to 174. But when you divide by 6, x is equal to, it becomes 29. So the value of x is equal to 29, choice 1. Number 10. So these two lines are cut by transverse, parallel lines are cut by transversal. Now, ERB is this angle, and then that's equal to 72. But I'm looking for RSC. RSC, that's our question mark. But as soon as you realize that this is 72, then this is also 72 because they're corresponding angles. But angle X is in fact supplementary to 72, so we get 180 minus 72 would have been equal to 108. And that becomes the measure of the angle which we are looking for, choice 4. Number 11. Here, once again, you see, when you look through this one, you can see that we have Z shape, and then these are interior angles. Basically, what I'm talking about is these two angles are alternate interior angles. That means they're congruent to each other. So we have to set them equal to each other. So 4x plus 30 is equal to 7x minus 9. By adding 9 to each side and subtracting 4x, then we get 39 must be equal to 3x. By dividing by 3, x now becomes 13. Now, then choice 3 becomes our answer for that one. Number 12. Here, relationship between these two angles are that they are corresponding angles. Since they're corresponding angles, we know that they are equal to each other. So 2x minus 30 is equal to x plus 15. That means we can subtract x and add 30. Then these cancels out. So we get x is equal to 45. And that's what they were looking for, 45. Choice 3. Alright, so it wasn't that bad, and we'll stop here, and I'll see you later. Bye-bye.